Good morning, ladies and gents. I hope this finds you well. Thanks for your flexibility today with the first day of Chapter 7. This is our last chapter, and hopefully, this gives you a little bit of insight into what we're going to be talking about here with inequalities. Hopefully, it maybe solve some issues that you had in your work in your last few virtual days. At any point along the way, when we give a problem like this, feel free to take a moment on a separate sheet of paper, go ahead and solve this guy and then put it on a number line, see if your solution matches the one that I'm going to give here momentarily. And so here's our first problem today. It says solve the inequality and then place your solution on a number line. So to do this, I'm going to start by distributing my 3. So I get 3x minus 6 is greater than 6. I'm going to add 6 to both sides. So I have 3x is greater than 12. And I'll divide both sides by 3. So I get a solution of x is greater than 4. I need to put that on my number line. So I'm going to come over here and I'll just start with 0, 1, 2. And I'll label all my little dash tick marks along the way. And you can kind of start wherever it makes sense for you whenever you're given a blank number line like this. And I need to have an open circle at 4 because I don't want to include 4. I only want the x's that are greater than 4. Those would be like 5, 6, 7, 8, 9, or 10. So I'm going to take this and I'm going to shade this guy to the right side. So I have x is greater than 4. So that's my first problem. Let's take a look at the next one. Maybe not. Let's see. I can clear my screen and click to the next slide. Okay, the graph the inequality on the graph provided. Next, list 2 points that would be solutions. So here I have what's called a 2-variable inequality where I have x and y. This sort of looks like y equals 4x. So just to start out, I'm going to kind of pretend that it is y equals 4x, and I'm just going to graph that. Y equals 4x is a y-intercept of 0 and a slope of 4. So I'm going to go up 1, 2, 3, 4, and over 1, and I'm going to put my point in. And now I'm going to draw a line through those 2 points. Something like that. Now, this is the line y equals 4x, but I don't want that. What I really want is y is less than 4x. So there's 2 things I need to consider. First is the line itself. Is the line going to be a solid line or a dashed line? Well, I want the y's that are less than 4x. I don't want the y's that are equal to or on this line directly. So in this case, I need to dash my line. So to do that, I'm just going to bring my eraser through here. And you could do this with your pen or pencil, and I'm going to dash that line. So far, so good. Put my arrows on the end. Now I need to decide if I'm going to shade above or below. And there's 2 ways that you can kind of think about this. I like to think about the fact that I would like the y's that are less than 4x or below. The y's that are below this guy are sort of down in this region, right? If I were to extend that line out. So I'm going to shade here, meaning all of the points in this region of the graph below the line are going to satisfy that inequality. The other thing you could do is test a point. Typically, I like to test the point 0, 0. But because 0, 0 is on the line, I have to pick a different point to test. I'm going to change my color. We'll go over here. I'm going to test an easy point. How about the point 2, 2? So how about I test the point 2, 2 and see if this is a solution? If 2, 2 works on my inequality, then I'm going to shade towards the 2, 2. And if it doesn't, I would shade away. We've already decided that we're going to shade below, so 2, 2 should make this inequality true. Let's test it. If I put 2 in for y is less than 4 times 2, that would give me 2 is less than 8. 2 is less than 8, that makes that true. So yes, indeed, I would shade below. So now my second part of the question is list 2 points that would be solutions. Well, the first point, I just found one. The point 2, 2 is a solution. And now really I could pick any point in this region, right? Notice I don't want to pick a point that's on the line because that line is dashed because I only want the y's that are less than my line. So I'll take another point. Maybe I'll go over here to 1, 2, 3, 4, 5, down 2. How about the point 5, negative 2? And again, any point in this shaded region would work. So there's a 2-variable inequality. Again, that should be review from your work the past few days. Let's click ahead. Uh, this is chapter 7. It's the last one, right? It's our last chapter of the year. This thing's going to wrap up here in the last full week of December that we are together. So if you're an A day person, that will be Tuesday the 15th, I believe, and then Friday the 18th if you are on Team B. So the number one name of the game here is inequalities in terms of our algebra review as we get ready for our Keystone exam. So let's take a look at another problem. And this time we have an inequality that's instead of a single variable inequality, it's a compound single variable inequality. And what that means here is I have two of these inequality symbols that I have to get involved. So let's see what happens here. So if I were to just have one of these things, so in other words, if I were to just look at just this side, if that was my original problem, I would solve this thing for x and then put it on the number line. So this is not going to look a whole lot different whenever I have two inequality symbols. Instead, what I'm going to do is I'm going to do whatever I do to the middle to get x by itself, I have to do to the left and to the right. This one's pretty easy. I need to subtract 5 to get x by itself. So I need to subtract 5 on the left and on the right. That gives me -2 is less than x is less than 1. So I need the x's that are greater than -2 but less than 1. On my number line, let's see here. If I go -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and 6. I need the x's that are between -2 and +1. I am just less than and less than here. I'm not equal to, so I need open circles. And then I'm going to shade everything between. If I tested a value in here, for instance, if I tested x equals 0, x equals 0 should make my original inequality true. So it should make this guy true. Let's test it. 3 is less than 0 plus 5 is less than 6. Well, 3 is less than, if I simplify the middle, 5 is less than 6. And that works out perfectly. So there's my solution. My solution are the x's that are bigger than -2 but smaller than 1. And on the number line, it looks like I've drawn here. So let's see if we can take a look at a more complicated example. Here we have just another step that we have to go through when we solve. So we'll keep it red this time. I'm going to start out by subtracting 4 from every side. So now it's no longer just one side, it's every side. So I have -4 is less than 2x is less than 6. And I'm going to divide everything by 2 because I need to get x by itself in the middle. So -2 is less than x is less than 3. So on my number line, I'll start out, I'll go -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and 6. I need open circles at -2 and at 3, and I have to shade the x's in between. Now, how would this problem change if I made this perhaps less than or equal to? Well, my solution would look like this, and then I need to shade this point in. Why is that? Well, that means x equals 3 is included in the solution set for this inequality. In other words, x equals 3 now makes my new inequality with the less than or equal to sign on the right true. Let's test it out and see if that's true. 0 is less than 2 times 3 plus 4 is less than or equal to 10. So 0 is less than, well, let's see, 2 plus 3 is 6 plus 4 is 10 is less than or equal to 10. And this is a true statement. 0 is less than 10, and 10 is less than or equal to 10, right? 10 is equal to 10. So now 3 made this true, so we'd have to shade it in. Let's take a look at one more example. All I did in this problem now is I switched the from 2x to -2x, but this is an important thing to denote here on how we're going to deal with this. So let's go to work. I'm going to subtract 4 from every side again. Same start as last time. Subtract 4, so I have -4 is less than -2x is less than 6. Now I need to divide by a -2. And as you should remember from your work at home and from last year in Algebra 1, whenever I divide by a negative, my signs switch. So I end with 2 is greater than x is greater than -3. If I were to simply rewrite this solution a different way, I could write it as -3 is less than x is less than 2. And that makes more sense to me. That's very similar to what I had before. So now when I put this in on my number line, -3, -2, -1, 0, 1, 2, I have open circles here, and I know I need the x's all in between. Those are the x's that make this thing true. Again, I could test anything. I could test x equals 0 or x equals -1 or even x equals 0.627. That's on the number line in here, right? X equals 3/5. That's on the number line between 0 and 1. All of those values would make my original inequality true. And that's why we have to write this as a solution set like this in this notation with our inequality symbols, because now we're talking about a set of solutions instead of just one single solution. Let's hop to the next screen. So sometimes we have two variable inequalities and they're not just given in y equals form. We're gonna have to solve these guys first. This is no big deal. We've solved equations for y in the past. Now it's just an inequality that we have to solve for y. I need to get y by itself. I need to end this thing with y over here. So let's get y by itself. I'm gonna subtract 3x from both sides. I end up with 2y is less than 4 minus 3x. 4 and 3 can't combine because it's 4 minus 3x. They're not like terms. And I made a mistake there. Let's get the negative involved. And now I have to divide everything by -2. And I'm going to divide every term by -2. So now I have y is, this was less than, but I've divided by a negative, so now it's greater than -2 plus, because a negative divided by a negative is a positive, 3 over 2x. So if you're okay with it, you can keep it that way. You could also rewrite this as y is greater than 3 over 2x minus 2. These are the same things. And now I can graph this solution. I'll go down to -2 as my y-intercept. I'll go up 3, 1, 2, 3. I'll run 1, 2 over, and I'll put my line in as straight as I can make it. I have my arrows. I got to go back to my inequality symbol. It is not equal to, it is just greater than. So I'm going to take my eraser and I'm going to erase to make this line a dashed line. And I know that this thing is, let's get a different color. I know that this is greater than, so I want the y's that are greater than or above my line. So I'm going to shade all of these points over here. And as you can see, my test point, if I were to test the point 0, 0 right here, if I put 0 in for y is greater than 3 over 2 times 0 minus 2. 0 is greater than, this becomes just a big 0 minus 2. 0 is greater than 2. 0, 0 worked. So I had to shade towards the 0, 0 side. That's a great example of a test point 0, 0 and using that when it's not directly on your line. All right, so let's clear this and go to the next screen. Okay, so this one's graphed for us, and I just went into Desmos and got a screenshot of this guy. So you have y is less than 3x plus 2. You can see that in red with the dashed line and shaded below. And y is greater than or equal to -x. So we have a slope of -1. It goes through the y-intercept 0, 0, and it's shaded above with a solid line. My directions are list 2 points that satisfy the system of inequalities. So now what we need here is we need points. I'll get a different color that's not blue or red. We need points that satisfy both of these. Earlier, we talked about points that would satisfy just one system, right? Because they'd be in that red shaded region. Now we need points that are in both shaded regions. In other words, we need any points that are over in here. So for instance, I could go crazy with this, right? 4, 0, bang, it's in my shaded region. If I tested 4, 0 on these two inequalities, it would make both of them true. I'd go to the point up here. I'd go to 4, 4. That's another point in the shaded region. I could even take a point down here. I could take the point 2, -2, because that's in the red region and on the blue line. Notice that point works. However, let's grab a different color. If I take a point that's on the red line and in the blue region, for instance, if I come up, let's see here, can I get a good point? How about right here? If I take the point 0, 2, 0, 2 is in the blue shaded region. It's going to satisfy my first equation. The problem is 0, 2 is on the dashed line for my red inequality. It's not going to satisfy both of these. I could test that algebraically. I could take 2 and put it in for y is less than 3 times 0 and put it in for x plus 2. If I simplify, I get 2 is less than 0 plus 2, or 2. 2 is not less than 2. Notice that's a point that's on the line, right? It's a dividing point. It's on the verge between what doesn't work for the red and what does work for the red. So this point does not count as a solution, whereas these other three that I have in this neon green here, all of those would work. Two of them, 4, 0 and 4, 4, were in the shaded region for both inequalities, while the point 2, negative 2 was in the red shaded region, but on the blue solid line. So it worked for my solution set. All right, here we go. We have two that we have to graph ourselves. One of them is not in y equals form, so we're going to have to do some work to get there. And then we have to answer the question, is 0, 0 a solution? So as always, feel free to try this problem on your own first before watching me go through the solution. See if your solution matches mine. I'm going to start out with the easy part here. I'm going to graph y equals 4x. I have a point at 0, 0. I'm going to go up 1, 2, 3, 4, and over 1. It's going to be a dashed line, so I'm going to put this guy in first. I'm going to note that this is my blue curve here, and I'm going to erase this thing to make this dashed. I need y is greater than 4x, so I got to shade everything that's above. Okay, so there's my region for my blue. Let's switch, and we'll go to red. I need to get y equals for this inequality before I graph it. I could graph it in standard form, but I'd rather graph y equals mx plus b here. So I'm going to subtract 4x on both sides. I get 4y is less than or equal to 8 minus 4x. I'm going to divide by 4, so I get y is less than or equal to 2 minus x. So I have this curve here. I could rewrite that if I wanted to as y is less than or equal to negative x plus 2. Notice I divided from this step to this step. I divided by a positive 4, so my inequality symbol did not change. Let's graph this guy. I have a y-intercept of positive 2. I go down 1, 1, down 1, 1. Here we go. Let's get my line going. Sorry if it's not perfectly straight. And this is a solid line this time because it's less than or equal to. I need the y's that are less than my line. I need the y's that are going to be over in this region. So the question is 0, 0 a solution? Well, let's see here. We'll go to neon green. Is 0, 0 a solution? Well, it's a solution to the red, right? It's in that red shaded region. If I plug 0 is less than or equal to 0 plus 2, I get 0 is less than or equal to 2. It works for my red inequality. But what about my blue inequality? It's on the dashed line. It's not going to be a solution for my blue inequality. If I tested it, I would get 0 is greater than 4 times 0. 0 is not greater than 0. It's equal. So it doesn't work for this guy. So my answer here is no, it's not. It is for the red, but not for the blue inequality, and therefore it is not a solution to the system, because in order to be a solution to the system, it has to satisfy both inequalities. All right. So that's that. What's next? Well, if you're a team A, we won't see you until Tuesday. Right now it is Monday. We won't see you till Tuesday, and then you'll have virtual days Wednesday, Thursday, and Friday after break. That team A on Tuesday, we'll be looking at our next geometry topics within this chapter. We'll be looking at polygons and looking at what happens when we look at shapes with 5 sides or 6 sides or 8 sides or 10 sides, and how the sides go together and the angles go together and all those things. So if you're team A, that's what you have coming up. I have nothing else for you over break, as long as you've submitted your chapter 6 patio project, right? That should be in. If you are team B and you're watching this, it is probably the Thursday. It is probably currently Thursday right after break. And so we will see you in class tomorrow, which is Friday, and we will continue with polygons. You should have submitted your patio project before break on Monday, and we will see you on Friday tomorrow. So again, your patio project should have been submitted at this point. If it's not, that assignment is closed. So you're going to have to email me and share those items with me so we can get those graded in. Feel free at this point to start your Chapter 6 corrections. Those things, as long as you took the test prior to break, those corrections or that test should be shared with you via email. So check your email inbox. We'll have a spot on Canvas for you to submit those in the slides presentation. That's going to be a virtual assignment soon, like next week soon. It's going to be a full day where you got to get that in. So you might as well start and get it done and out of the way, and that'll clear some time for you on that virtual day coming up soon. So feel free to use time in class today to get after that. Again, Team A, there's no work due over break as long as your patio project's done. Please enjoy your break. Stay safe and healthy, and we'll see you soon.